Mm-hmm. I do want to talk just briefly about number 9 and number 15. In all my years of teaching, I don't know what it is, but people somehow don't want to see 0 as an answer. And I've seen a lot of people on 9 and 15 write no solution. But here's my question for you. Is 0 a number?
Yes.
If 0 is a number, why can't it be my answer? And the answer is, it can. 0 is a number. It's valid. If you've worked it out and you end up with something equals 0, it's okay. The only time you're going to have no solution or all real numbers is if there's no variable left. And you end up with a true statement or a false statement. Something that could never be true or something that no matter what you do will always be true. But if you end up with 25x equals 0, what's x? 0. That's okay. 0 is just as much a number as 50, a negative 150, or 2/3. Doesn't matter. Everybody had a chance to check through their problems? Okay. Today we are going to start talking about geometry. This is actually out of section 1.2. If you turn to page 13 in your textbook, you could actually see this listed there. Now, if you ever notice a little blue box around something like this, what it is this is kind of supposed to be hidden. And for the sake of taking notes, I've unhidden it so that we could talk about it a little bit. I will say that the first chapter of geometry is like learning a whole new language. You've got to learn how to write and speak in terms of geometry. It's a little different. So we're going to talk about some definitions and some postulates, some axioms that you may or may not have seen before. And you have to accept that a postulate or axiom is accepted as a statement or fact. As we say that there's 3 undefined terms. Well, if they're undefined, it's going to be pretty hard to do anything with them if they're undefined. And the first undefined term happens to be point. And the reason it's undefined is we can only explain it by using examples or give you a description of what a point is. A point indicates a location, but it has no size. It has no length, it has no width, and it has no height. Down to naming a point, this is where we have to start looking at learning how to speak in terms of geometry. When you're naming a point, you would put point out in front of it. And you'll notice that this is a capital letter. If you're one of those people that sometimes uses capital letters and sometimes uses lowercase letters, we have to break that habit in geometry. If they're using a capital letter, you need to make sure that you're also using a capital letter. If they've asked you to label a point, you need to make sure that you're labeling it with a capital letter. Likewise, where these 2 lines intersect, that represents a location as well, and this would also be point P. Do I have any questions about our first undefined term? Now, I am going to tell you, if there's a day where it would be really easy for me to go to the next screen and go too fast for you, it would be a day where I already have things kind of pre-done and there's no work for me to do. If I do that and I've gone too fast, what should you do? You should tell me. Let me go back. It's still there. Nothing's happened to it. Is everybody good with this one? Can I go on? Okay. A line is our second undefined term. A line is represented by a straight path that extends in two opposite directions without end. In other words, it has one dimension. It has length. But it doesn't have a width or a height. When you are naming a line, you can name it in one of two ways. You can use 2 points to name it. I could say RS with a line symbol over the top. Notice that it has arrows on both ends. I could actually also say SR. It doesn't matter which points and which order I use so long as they're on that straight path. The other thing that you could do is you could use a lowercase script letter if they've put one there on the line, like they have here. You can no longer use the symbol, so you'd actually have to write line and use that script L. Now, this is pretty simplistic. How many, if I had asked you to name this line, how many different answers could I see in the class? How many? How many? There's 3 different ways I could have named this line, isn't there? And the minute I add another point to this line, there's a lot of different ways. And if I put another point on here, there's a lot more ways that I could name the same exact line. So just because your answer and my answer don't look the same, doesn't mean your answer is wrong. And the answer to that is no. There's certainly 3 different ways in this case, and the more points that I put out here, the more possibilities there are for naming it. Points that are on the same line are said to be collinear points. In other words, R and S in this picture are collinear. Co kind of means together. Linear means together then on a line. Points that are not on the same line are simply said to be non-collinear. If I put a point somewhere up here, I could say that R, S, and A would be non-collinear points. Why is it line L? That's just one of those things that you have to take as a notation. It's the way we write things in geometry. It's like learning how to write your alphabet. Why do we make an A like we do? Because somebody told us that that's the way an A was made. There are 2 different ways that you can name a line. You can use 2 points with the line symbol over the top, or you can use a lowercase script letter if they've put one out on the end. Okay? When we go to a plane, you're going to find out that there's 2 different ways that you can name it, and it's going to look a little different as well. You'll notice these 2 little asterisks beside this. if you turn to page 13, you're going to notice that this is postulate 1-1. Through any 2 points, there is exactly one line. The intersection of 2 lines is always going to be a point. And in the picture that was drawn up here, in fact, the intersection of the 2 lines would be point E. So we've had 2 undefined terms so far. A point which had no dimension, a line that has 1 dimension, and the next one is a plane which has 2 dimensions. It has length and width, but it has no height. When they draw one, they typically use some kind of parallelogram to represent that plane that's there. Although it's showing that it has an end, the plane is what? Infinite in length and infinite in width. It would continue on off the screen in both directions. But it wouldn't pop off the screen because it doesn't have a thickness to it. Again, learning how to write in geometry, there's 2 different ways that we can name a plane. We can name a plane with 3 non-collinear points. So I might say plane ABC. In fact, naming it this way, you can see A, B, and C are not collinear. Naming it with 3 non-collinear points, how many different names could I actually list here under number 1? It wouldn't be 9. It wouldn't be 3, but it's somewhere in between. There's actually 6 different names. I could say ABC, I could say ACB. I could say BAC or BCA. I could say CAB or CBA. There's actually 6 different names that I could list here. The reason I point that out is just to show you again that just because the way I answered something and the way you answer something look different doesn't mean that yours would be wrong. Not necessarily. The other way that you can name a plane is using an uppercase script letter. So I could say, in this case, plane M, because you can see they've put that uppercase script M there in the corner. And again, I think if you looked on page 15, you'd find that this is also a postulate. Through any 3 non-collinear points, there is exactly 1 plane. And I want to go up to the board and show you why that is true. Collinear. If points are on the same plane, what do you think they're said to be? Collinear meant together on the same line. What do you think they're going to be if it's together on the same plane? Co what? Coplanar. That's what it is, coplanar. And if they're not on the same plane, what do you think it would be? Non-coplanar. And you don't need to draw this little picture that's down here. Some of the values might even be hard to see on this screen. But it is a representation of what two planes look like when they intersect. And you can see their intersection is here. And the intersection of two planes is always at a line. So our three undefined terms. Point has no dimension. It's just a location. A line has one dimension. It's infinite in length. It's a straight path. A plane has two dimensions. It's represented by a flat surface. It has length and width, but no height. And you should be able to name a point, a line in a plane. Are there questions so far? I do not want you to draw this. It's going to sound silly, but here's what I want you to do. I want you to stare at the picture. Don't look anyplace else. Just look at the picture. Please don't draw this one either. It's why in geometry that when two lines come together, two planes come together, that they take the time to label all the individual pieces that are there. It gives us a way to clearly define the left, the right, the top, the bottom, and that kind of thing. Now, you ready for a bad math joke today? How many planes are in this figure that's shown up here? There are 6. It has 6 sides in this shape. There are 6 planes. Okay? No, there would be 8 if you're going to count the inside and the outside. Just as a joke. Okay. There is the plane that's on the left, ADH. There's a plane that's on the right, CBF. There's a plane on the bottom, HEF. There's a plane that's on the top, ADC. There's a plane in the front, HDC. There's a plane in the back, AEF. And yes, those could have been named a number of different ways. Name 3 collinear points. Remember, collinear means together on a line. AIB would be 3 collinear points. AIB. There is one other set that I could list. GJF. Now, I am going to tell you, when you see something like this where it says name 3 coplanar points, they are actually talking about what's physically drawn in the picture. I don't really like this style question because if they're talking about 3 coplanar points, is it possible for me to draw any 3 points and not have them exist on a plane? No, because in order to label a plane, we label it with 3 what? 3 non-collinear points. So any 3 points would be on a plane. But specifically, they're talking about naming the planes that exist. So they really wouldn't want you to list D, H, and B. Why? Right, it's not one of the ones drawn. It does exist. It would kind of be a diagonal plane through this figure. So if they ask you something like that, they are specifically asking you what exists in this particular picture. So I could have said DAE. I could have said DHE. In fact, how many different possibilities do you think there would be now? There'd be a lot. There way more than 16. There's probably 16 or more on each plane, especially when a plane has 3 collinear points on it. We become a lot of different possibilities. Okay?
Does that mean that the 3 collinear points that you put down, would that also work for each drop?
They would also be coplanar. In fact, they're together not on one plane, but on how many planes? They're on 2 different planes in the picture. G, J, and F are on the plane that's on the right side, but they're also on the plane that's on the bottom side. So there would be lots of possibilities when you're talking about 3 coplanar points. Everybody okay with collinear and coplanar?
If you did write down just 3 of the any points for the coplanar, would that be incorrect?
No.
I mean, if on the question?
It would be correct. They are coplanar. Okay. Next, a line segment. This is actually a defined term. It is part of a line that consists of 2 endpoints and all the points between them. When you're naming a segment, you must name it with its 2 endpoints, and you must put the little segment bar over the top. Notice there are no arrows. It doesn't matter which order those 2 endpoints are listed, but they do have to be the points that are on the end. If it is listed this way, and there is no segment bar over the top, this is talking about the length of the segment. This represents a picture, the actual drawing of the segment. This represents a number, the distance or the length between P and Q. Assignment is out of that workbook. Okay? It's actually going to be page 7 and 8. It'll say Form G up in the corner. Most everything that we do is going to come out of this workbook from Form G. I want you to keep it. Put your name on it. Take it home with you. Bring it back to class. The textbooks I'll keep here. The workbook I want you to take with you and bring it back and forth. We may use it a lot. We may not use it as much by the end of the year. But at the beginning of the year, we're going to use it quite a bit. So please keep up with it. Put your name on it. Have a great weekend. 1 through 29. It seems like a lot, but I promise you, it won't take you as long as it did to work out the 13 questions.